Okay, before we go on and build our model and draw conclusions about a population, we need to have some definitions down, okay? What are these definitions? The first definition you need to know is a statistic. A statistic is a number that describes some characteristic of a sample. It is computed from the sample, okay? This is something we can compute. If we don't compute it and it's given to us, it's describing the sample. All right, with the statistic, there's some notation that comes along. The typical statistics that we use with the sampling distribution of a statistic when we build that model is the statistic we use is p hat. What is p hat? P hat is a proportion. It's describing a sample. It's a percentage that's describing a sample, okay? When we calculate the proportion, we calculate it like this. It is part of the total sample, okay? And we divide it out to find that decimal. Sometimes it's given to you. They'll give you the p hat. They'll say like 70%, 62%, so on and so forth. That's easy, but sometimes you have to calculate it. They'll give you the part of, they'll give you the total sample, and you have to go ahead and divide that out. We deal with p hats, ladies and gentlemen, when we're dealing with categorical variables. The other statistic that we use is like what we just used in our example with our class, or my class from last year, and I described it. That's X bar, and that's an average of a sample. What did we use in our class activity? Again, in our class activity, we used X bar, and we described it as equal to, average amount of sleep 3 students got that night. Okay, let's move on. The next definition that you need to know is a sample. Well, what is a sample, Lexi? You know what it is? It's the part of the population for which you want to draw conclusions about. We describe a sample as n, okay? So we say n, lowercase n equals your sample size. In our activity, our class activity that I just described, our sample size was n equals 3. Next definition, okay, next definition. Let's talk about what a parameter is. A parameter is a number that describes some characteristic of the population. It's not unusually, it should be usually. Sorry, guys. Usually, it is not known, and we never compute it. It may be given to you, okay? It may be given to you, but we never compute it. How do I know the difference between a parameter and a statistic? Remember, a parameter describes the population, so you just have to ask yourself the question, what number is this describing? It will tell you in the problem. It is, you do need to know the difference. You need to know how to pick the two out, okay? For this unit, it will be given. For the next coming unit, sometimes it's not given. It just kind of depends on the problem, to be honest. What is the notation? The notation for a proportion of a parameter is P, okay? And what we say about it is we say P is equal to the true proportion of ... okay? So the true proportion of students that are going to the University of Minnesota, for example. Another parameter that you guys deal with is mu, okay? And how we describe that is we say mu is equal to the true average ... So in that class activity, we would have said mu is equal to the true average hours of sleep students get at night. Okay, so we want to talk about sampling variability right now. Give me a second here, guys. Okay, whatever, we're good. Let's talk about sampling variability. What is it? Okay, what we know is the value of statistics, of a statistic, it should be statistic singular, varies in repeated random sampling. Okay, it varies in repeated random sampling. We saw this in this image here, right? In this dot plot. There's variation here, okay? Not every single person, when they hand me that X bar, that little sheet of paper on what they found when they found the average number of sleep hours, it's not always the same. Sometimes it is, but there's variation. We know that in statistics, okay? There's going to be variation. To decrease that sampling variability, you need to increase sample size, okay? You need to increase sample size. Lastly, let's talk about law of large numbers. Law of large numbers is, as trials increase, the experimental probability approaches the theoretical probability. This will be shown by the center of the sampling distribution of the statistics, excuse me. So what do I know here, guys? Is as I would increase my trials here, things are going to start to stack up over the truth. And we talked about that already. All right, ladies and gentlemen, this was our video over definitions. Thanks so much. And we will see you for our next video.